decide which method and some template answer for your exams. Okay. So first of all, definition of a salt. Okay, a salt is the ionic compound formed when a metallic ion or an ammonium ion replace one or more hydrogen ion of an acid. So let's say for example HCl. Okay, initially HCl, after the reaction with sodium hydroxide, right, it will become what? NaCl. So you realize that one of the hydrogen of hydrochloric acid is replaced by Na. Okay, so whenever a hydrogen ion is replaced by a metal ion, this is what we call a salt. Okay, so this one make sure you memorize it, because once in a while in the exam they will ask for the definition. Okay, next one. Okay, so for this table, for this topic, right, you need to memorize the solubility table, so which I already went through in QA. So just a fast recap: all sodium, potassium, ammonium salts are soluble. All nitrate salts are soluble as well, and then chlorides are all soluble except for lead chloride and silver chloride. Sulfate salts all are soluble except for what? These three: calcium sulfate, barium sulfate, and lead sulfate. Lastly, carbonate ions. Carbonate ions all are insoluble except for your sparse salts, meaning sodium, potassium, ammonium, and other group 1 carbonates. Okay? Methods of preparation. So the first method, acid with excess insoluble solid. Okay, so for this method, right, is for soluble salt except for sparse salts. Sparse salts basically means what? Your sodium salts, potassium salts, and ammonium salts. Because if you are forming these three salts, right, you are using another method which we'll explain later. So coming back for this method for soluble salt except for sparse salts, right? So insoluble salts, because you mentioned here that you need acid. Okay, so acid with an excess insoluble solid. So insoluble solid in this case, right, you have three possible options. So the first one, metals, bases, and carbonates. So metals, right, is important to take note that you can't choose any metals that are too reactive or unreactive. If it's too reactive, right, when it reacts with acid, right, there might be an explosion or the reaction will be too violent. Okay, and then unreactive metals cannot be used as well because acid does not react with unreactive metals. Okay, and then carbonate, you will form CO2 gas, but bases is the best option. Bases basically means metal oxide. Okay, so your reaction will be something like this: acid, okay, acid plus an insoluble solid. So most likely you will choose a base, okay, to give you products. So that's for the first method for any soluble salts except for sparse salts. For second method, titration, okay, is for soluble salts as well, but it's for sparse salts, basically sodium, potassium, and ammonium. Okay, so whenever you have a soluble salt, right, you must ask yourself whether is it a sparse salt or is it not a sparse salt. If it's not a sparse salt, you will use method 1. If it's a sparse salts, you will do titration, method 2. Okay, so for titration, it's actually a neutralization. So neutralization means what? You need a acid and alkali. Okay, then will give you a salt and H2O. Okay, so you have the H here. This is acid. Okay, the H plus is from the acid, and then this is something alkaline, which is OH. Okay, the third method is precipitation. Is for insoluble salts. So for soluble salts, you can have either method 1 or method 2. But for insoluble salt, right, it's definitely precipitation. Okay, so these are the three methods that you have to know. For insoluble salts, right, what are the requirements? You need 2 soluble reactants. So your 2 starting reactants, right, have to be soluble, meaning solution or equals. Okay, so the best choice is what? You can use this as a template answer for your exam. You can choose sodium something plus something nitrate. Because all sodium salts we learned before just now are all soluble and all nitrates are soluble. So these two definitely will be soluble. So you just need to fill in the blanks here. Then I'll give you a PPT, a solid, insoluble solid plus another salt. Okay, so next we will look into detail the first method. Okay, acid with excess insoluble solid. So let's look at this one. Example 1, steps to form what? Copper 2 sulfate. Okay, copper 2 sulfate. So if you realize, if you go back to your solubility table, right, all sulfates are soluble except for lead, barium, and calcium. So as far as copper sulfate is concerned, it's soluble. Okay, so it's soluble, but it's not a sparse salt. It's not potassium, sodium, or ammonium. It's copper. So we'll choose the first method. Acid with excess insoluble solid. So this one you have 3 choices. So usually we'll choose the base, metal oxide. So in this case, what acid are you going to use? What acid? So for what acid to use, right, you will look at the anion. the back part. So it's sulfate, so you use sulfuric acid. And then the front is copper. Copper base is what? Copper oxide. So you use sulfuric acid and copper oxide. Okay, so what acid to use, right? You have to look at the compound you want to form in the end. Okay, so step number 1, you add what? Excess copper oxide, meaning the solid, into sulfuric acid and stir until no more copper oxide can dissolve. Okay, so why do you add excess? Because you want to ensure all the sulfuric acid have been completely reacted, okay, completely used up. So at the end of the reaction, right, there's no more excess sulfuric acid. That's your objective. So you will keep adding copper oxide until it's in excess. Step 2, okay, because there's excess, so you need to what? Filter the mixture to remove the unreacted copper oxide, which will be in a solid state, okay, floating in a solution. So you have to remove it by filtration. Third, you will heat the filtrate. So the filtrate that you get from your filtration step 2, right, will be your copper sulfate solution. But what you want is the crystal, not the solution. So that's why you need to heat the filtrate to saturation. Okay, so you're trying to do crystallization here. So you let it cool to form crystals, filter the mixture to obtain the crystal as the residue, and then lastly, you wash the crystal with distilled water and dry with filter paper. So from step 3 to 6, right, is basically trying to carry out crystallization. Okay, so for the first method, acid with excess insoluble solid, these are the template steps. Okay, so that's why I put a star, so you can actually just memorize. Okay, so you just need to change your 2 reactants accordingly to what the question is asking, but the rest of it will be exactly the same. Okay, so this is your template answer for the exam for the first method. Okay, so sometimes they might ask you for the balance equation. So this one, H2SO4 plus CuO will give you copper sulfate aqueous plus H2O. Okay, so take note, copper oxide will be in a solid state. So you will remove the excess, then you get your solution, then you do crystallization to get a crystal out. Okay, and then make sure you balance it, of course. Okay, method 2, titration. Let's look at example. Step to form what? Sodium chloride, NaCl. So if you look at your solubility table, all sodium salts are what? Soluble. And then since it is a sparse salt, so we'll do titration, which in other words is a neutralization, require acid and alkali. So what acid plus what alkaline? Okay, so if you look at NaCl, which acid has chloride? So it will be HCl, and then here obviously will be Na. So it's HCl plus NaOH. So HCl will be hydrochloric acid, and then NaOH will be your sodium hydroxide. So first step, you will prepare what? 25.0 cm3 of HCl in the conical flask. Next, you add indicator. You add a few drops of methyl orange into the conical flask. Okay. Step 3, you will titrate with sodium hydroxide from the burette. So basically, your burette will be filled with sodium hydroxide. Okay. And then when you step 4, record the volume of NaOH used for the solution to change color. So as you add your sodium hydroxide into HCl in the conical flask, it will keep adding until one drop it will changes the color. Okay, then you have to record down the volume of NaOH used. Then next, you'll repeat the step 1 to 3 without adding methyl orange. At the start, you will do the experiment with methyl orange is because you do not know how much NaOH is required. But once you know it from step 4, right, you'll redo the experiment again. But in this case, you don't have to add any methyl orange, okay, because you already know the exact volume of NaOH needed. Okay, and then your methyl orange exists like an impurity if you add it in a second experiment. Okay, so your second titration do not need to add any methyl orange. After that, step 6, okay, so you heat the filtrate to saturation, because after step 5, right, the solution that you obtain is just nicely neutralized. There's no excess acid, there's no excess alkaline. Then the filtrate will just be what? NaCl. But in this case, you need to get the crystal of NaCl. So that's why you will heat the filtrate to saturation, then let it cool to form crystal, filter the mixture to obtain crystal as residue. Then lastly, you will wash the crystal with distilled water and dry with filter paper. So from step 6 to 9, right, basically is your crystallization, which is very similar to method 1. Okay, crystallization. So these are the steps for titration. So I can put a star here so you can memorize. This is a template answer. So you just need to change the acid and the alkaline that you use according to the different questions. So what's the overall equation? HCl equals plus NaOH equals give you NaCl equals plus H2O liquid. So this one is a neutralization. Acid plus alkali give you salt and water. Okay, so I repeat, Na is a sparse salt, so it's a soluble salt. We'll do titration. So meaning whenever you see the question, you need to know whether it's soluble or insoluble by looking at your solubility table. Then you can determine which method to use, and then requirement to observe accordingly. Okay, step 3, method 3, precipitation. So steps to form what? Barium sulfate. So if you refer to your solubility table again, barium sulfate is insoluble. So if it's insoluble, you need to do precipitation, which tells you that you require 2 soluble reactants. So a shortcut is what? Sodium something plus something nitrate. So if you want to form barium sulfate, right, what do you need? You need sodium sulfate here plus barium nitrate here. Okay? So you choose sodium sulfate plus barium nitrate. Step 1, okay, you will mix these 2 reactants together. Mix sodium sulfate and barium nitrate together in a beaker. Then next, you will filter the mixture to obtain barium sulfate as the residue. Then lastly, you will wash the residue with distilled water and dry with filter paper. So this will be the solid. This will be the residue in the end. Okay, barium sulfate. And then the balance equation, sodium sulfate plus barium nitrate give you barium sulfate plus sodium nitrate equals. So you realize that barium sulfate in this case, right, is a what PPT, okay, solid. Okay, so you can remember these 3 steps as the template answer for precipitation. Just change the reactants accordingly to your question. Okay, so now let's try some practice question. Which method is used to prepare the following salts, and write down the reactants and the balance equation? So let's look at the first one. You need to form AgCl, silver chloride. Okay, so silver chloride, if you refer to your solubility table, it is insoluble. So for insoluble salt, you must use precipitation. Okay, so precipitation, what reactants do you need? 2 soluble reactants. So I will choose what? Sodium nitrate and something chloride, which is soluble, which is sodium chloride. Okay, silver nitrate plus sodium chloride. So in the end, the balance equation will be AgNO3 plus NaCl will give you AgCl plus NaNO3. So you realize that AgCl here will be solid. Okay. Okay, so if you look at the solubility table, magnesium nitrate will be soluble because all nitrate salts are soluble. So, but if it's a sparse salt, it's magnesium, it's not a sparse salt. So we will do the first method, which is acid with excess insoluble solid. Okay, so what are reactants? One must be an acid, the other one must be an insoluble solid. So acid we will use what? Acid has nitrate, so it will be nitric acid. And then this one will be a base, so we will choose magnesium oxide. Okay, nitric acid plus magnesium oxide. So the balance equation, HNO3 plus MgO will give you MgNO3 and H2O. So you just balance the equation. Okay, so take note, magnesium oxide in this case will be in solid because you're going to add in excess and then you're going to filter. Okay, insoluble. Okay, to ensure all the nitric acid have been completely used up. And then the last one, potassium sulfate. So potassium is a sparse salt, so it's a soluble salt. We will use titration. So titration, you need 1 acid and 1 alkali. So which acid? Sulfuric acid and potassium hydroxide, because potassium hydroxide will be alkaline. Okay, so your balance equation, H2SO4 plus 2KOH give you potassium sulfate here and water. So make sure you balance the equation, and that's it. Okay, so these are the ways to determine which method to use, and then what reactants to come up with, and of course the steps. So you can just memorize the steps that is provided in the previous slides. Okay, so that's the end. So don't forget to like, share, and subscribe. Okay, bye.